Hi everyone. Oh yeah. Hey, welcome to this number fun nugget. I love maths, Dave. I'm glad you like maths, Alie, because we're going to do quite a bit today. Square numbers. Indeed, we're looking at square numbers today. I like your wig. Well, I'm not sure I like the wig. I had to wear the wig because he made me do it. Hey, I'm the boss. No, you're not the boss. In fact, I'm going to take it off because it looks a bit silly. Hey. You still got your pineapple glasses on, though. They're my learning glasses. Oh, of course they are. He loves learning. Today we're going to learn all about square numbers. Hey! So, Alie, let's just get on with it, shall we? We need your rhyme. Where's your rhyme? Here it is. What's the story? What does it look like? What do I need to know? What can we reason? What's the challenge? Whoops, I need to go. Bye. Hold on. It's not whoops, I need to go. It is. It's not. I need the loo. Bye. Come back here. Why? Listen, all those things we're going to talk about in terms of square numbers. What's the story behind it? What does it look like? What do we need to know about it? What can we reason? What's the challenge? Whoops, I need to go. No, it's not. Come back here. Hey. But the whoops, I need to go. No, not that bit. Wait before you go. Is at the bit at the end where I'm going to give you a challenge and then I'm going to encourage you to pause the video and then after you've paused it to unpause it and then we'll do wait before you go because we'll give you our solutions. We will indeed. Right. You ready to go?
Part 1. What's the story?
What's the story, Dave? Well, I'm after a story from you, Alie. 4 times 4 equals 16. What is the story? 16's a square number. Well, I know it is. What's the story behind it? Well, on my planet, Dave, that's Eric, we measure length in goo gashes. You measure length in goo gashes. About how long is a goo gash? 50 metres. Right. And when you buy a field, Dave, it has to be square in the area. Oh, the area of any field is square. And it's goo gash. It's to do with goo gashes. Yeah. I've got a board. I always got a picture. So this is like my fields, Dave. So this is a field. Yeah. And it's 1 goo gash by 1 goo gash, is it? Yeah, it's 1 square goo gash. Oh, I see. And is this another field? It is, Dave. So you got 2 goo gashes that way. Yeah. And 2 goo gashes that way. Yeah. It makes 2 square it's 2 squared, Dave, which is 4 goo gashes. I see what you mean. So it's 2 squared, because it's 2 that way and 2 that way. 4 goo gashes. 1, 2, 3, 4. Is it 4 goo gashes? 4 square goo gashes. Ah, because here's 1 square goo gash. So it's 4 square goo gashes. Yeah. So what's that got to do with 4 times 4? Well, it's like 4 one way and 4 the other way. You mean it's 4 that way and 4 that way? It gives you 16 square goo gashes. I see. I've just remembered something, Dave. Hold on. What have you remembered? I remembered about the 1 squared bit. Oh, your glasses are coming off. Go on, what have we got? We've got 1 squared here. So you're thinking 1 squared. I know the names. Oh, he knows the names. So my glasses are falling off. Oh dear. So what's the 1 here? What's that called? Base number. Your base number. That's your base number. And the little 2 bit up there is called your index. Index. So these are called indices when they're multiples of index, but that's your index and that's your base, and the index tells you just how many times you need to multiply that number. So if I had 2 cubed, what would it mean, Alie? 2 to the power of 3. It will mean 2 multiplied by 2 multiplied by 2. So actually the index tells me how many times I need to multiply that number. I love it, Dave. And my glasses are falling off. I've got to go and rescue them. Bye. Oh dear. Goo gashes, Dave. Great name. It's a great name. I'm thinking that's sort of a good story, Alie, but I'm really interested in this.
Part 2. What does it look like?
What does a square number look like? Well, you showed us a couple there. I've got Cheeky Monkey's board from another session he did. Oh yeah, and he had 1 and 100. Both of these are square numbers. Because 1 has got that cube has got a square face, and this 100 piece here, this cuboid here, has also got a 100 face. It's a 10 by 10 face makes 100. I love it, Dave. So there. Oh dear, board's falling apart. And this I found the other day. Oh, what's it got, Dave? Well, it looks sort of square, doesn't it? It's like a square face. It's actually got 100 holes in it. You've got 10 that way and 10 that way. It's a square number, Dave, and you can see. It's a square. So we got Squares all over the place. That was a bit noisy. I'm sorry about that. Just dropping things. A bit like Cheeky Monkey. Well, a Cheeky Monkey's always dropping things. But have a check at this video, because I did this video a few minutes ago. See what you think of this. Oh, we got counters, Dave. On the board. I have. 1. Oh, you now got 2 squared. Absolutely, you've picked it up like the idea. That's 3 squared, Dave. You added some grey ones. I did. Oh, I can see my fields coming on. 4 times 4. That's what it looks like, Dave. That's a 4 times 4. 16 square goo gashes. See what you mean. 5 times 5. Now the green's on. It is that. Now there is 5 multiplied by 5. There's 25. 25 counters on there. Oh, I like this, Dave. 6 times 6 is coming. There it is. 6 times 6. 36. You're getting good at this. I'm loving it. I'm predicting, Dave, this is going to be 7 times 7. It is 7 times 7. I can see a pattern. Can you? I wonder whether children can spot a pattern. There's definitely a pattern, Dave. Well, I think there's probably a pattern on there. 8 times 8 coming, Dave. It is 8 times 8. Now I've added the purple. Oh, it's on there, Dave. Oh, goodness me, you're adding more and more counters every time. I wonder how many. I wonder how many I'm adding. They're the brown ones. The brown ones. That when I've got the brown ones on, it's 9 times 9. Yeah, well done, you've got it right. It is 9 times 9. And there's a big stack of red ones. How many? Wow, I wonder how many we're adding. In fact, there's 10 going down there. Because the whole board itself is a square number board. It's actually a 100 board. 10 to add 9. 19. Give it a shake. Oh, look. Wow. I'm loving that, Dave. That is square numbers supremely. I'm glad you like that, Alie. And I've got one more bit of square number, because I'm thinking, what does it look like? I'm trying to show you as many pictures as I can. Oh, it's your football stadium, Dave. It's my football stadium. And if you remember...
Mathematical adventures around the house.
Myself and my wife made the football stadium out of all these bricks. Oh, floodlights, Dave. We need them later. We do need the floodlights later. That'll come later in the programme. This is going rather quick, Dave. It is rather quick. It took a bit longer in real life. This is a bit of a time-lapse thing we're doing here. Oh, it's the stadium. Oh, it's the pitch. Oh, look, and there's the whole stadium. I love it. But you know, when we were making that, Alie, look, when I was setting everything out, I actually spotted some things in arrays. So on that 8 times 8 at the top, there's actually 8 studs one way, 8 studs the other way. 8 times 8 is 64. You can see it's like a square there. And the bottom left-hand corner, 2 times 2 equals 4. Those are like the corner flags that we used. And then there's an array of 4 times 4 sort of arms. They are random arms. And on the right hand side, those are the 5 times 5 is 25. Those were the bricks, if you like, that the players played on. I'm loving it, Dave. Oh, that's a big one. It's a big one. Actually, there's studs on that one. There's 20 one direction and 20 in the other direction. Goodness me. And you can tell it's a square, can't you? Yeah. Do you know how many studs? 400, it says on the board. It does. It's actually, so 400 is definitely a square number. And I had that on my on the board there. Isn't that amazing? I love square numbers, Dave. Why are they not hexagon numbers? Oh, well, they're not called hexagon numbers or pentagon numbers, because it's basically, it's the creation of a square in the array format. It looks like a square in an array. I'm loving it. I'm loving it as well. So what's it time for, Alie?
Part 3. What do I need to know?
What do you need to know? Well, the thing is, when it comes down to it, you do need to make sure you know the vocabulary. Product, that's right, because a square number is a multiplication thing, really, isn't it? So we've got 4 times 2 there, but your calculation earlier on was 4 times 4 equals 16. So the first 4 is the multiplicand, next one is the multiplier, but the answer in any multiplication is called the product. I love it, Dave. And the thing is, I've got a song that can help us with it. So I've got a definition there, slightly greyed out on there, but it goes, a square number is the product of a number with itself. You say it early. A square number is the product of a number with itself. It is indeed. So it's the product, it's the answer when you multiply a number with itself. So I've got 5 times 5 is what? 5 times 5 is 5. Sir! Indeed it is. So you salute when you say the sir bit, because this is a bit of a marching song, a bit like Table Troopers. And then there's another bit in the song which is designed to be like a catchy bit so you don't forget it. So it goes 1, 4, 9, 16, 25, 1, 4, 9, 16, 25, 36 and 49, 36 and 49. It carries on like that. And that's designed just to get in your brain so you just remember the square numbers up to 100. So here's the song. Is that you, Dave? No, that's not me. That's just 2 soldiers. Can you hear the marching coming? Is that you, Dave? That is me. And I'm marching away. I wonder what a square number is. Join in, everybody. March in, please. Now. Get those legs moving. Oh.
A square number is the product of a number with itself.
A square number is the product of a number with itself.
A square number is the product of a number with itself.
A square number is the product of a number with itself.
1 times 1 is what?
1 times 1 is 1, sir.
2 times 2 is what?
2 times 2 is 4, sir.
3 times 3 is what?
3 times 3 is 9, sir.
4 times 4 is what?
4 times 4 is 16, sir.
5 times 5 is what?
5 times 5 is 25, sir.
6 times 6 is what?
6 times 6 is 36, sir.
7 times 7 is what?
7 times 7 is 49, sir.
8 times 8 is what?
8 times 8 is 64, sir.
9 times 9 is what?
9 times 9 is 81, sir.
10 times 10 is what?
10 times 10 is 100, sir.
1, 4, 9, 16, 25.
1, 4, 9, 16, 25.
36 and 49.
36 and 49.
64 and 81.
64 and 81.
100. Job done.
100. Job done.
And again. 1, 4, 9, 16, 25.
1, 4, 9, 16, 25.
36 and 49.
36 and 49.
64 and 81.
64 and 81.
100. Job done.
100. Job done.
A square number is the product of a number with itself.
A square number is the product of a number with itself.
A square number is the product of a number with itself.
A square number is the product of a number with itself.
Square numbers.
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 Oh, I like that, Dave. You know, well, hopefully it'll help you to remember your square numbers. Oh, Dave, yeah. Can you tell them the story? Oh, yeah. A few years ago, there was why have you got? Why have you got that wig on? I felt like it, Dave. You felt like it. Oh dear. There was a question in the year 6 SATs in the tests where 11-year-olds sat that said which 2 square numbers add up to 100. And I know lots and lots of children, because the teachers have told me about it, just when they were doing the test, started just jotting things down. They went 1, 4, 9, 16, 25, 36 and 49, 64 and 81, 100. Job done. And they just jotted them down. They were using it as a memory thing. So they remembered the song. And then, of course, it became really obvious, because actually 36 has 64 equals 100. They were able to spot that pretty quickly. So it came down to the fact that the song was designed just to be a memory song. So there we are. So that helps, doesn't it? So it's now time for this.
What can we reason?
Okay, Alie, I'm going to give you a couple of things that we can reason about. Oh, it's a picture, Dave. It's a picture. It's actually a picture of all the square numbers up to 100, which is what we need to learn. We've just seen that in the video, Dave. Yeah, but we haven't seen it exactly like that, have we? What can we reason? Okay, let's see if we can have a little bit of a think about those numbers. I wonder what you guys can reason at home about them. I can see, Dave, that 100 has 4 square numbers in it. Oh, what do you mean? 5 times 5. Oh, I see. So it's actually got 5 times 5, add 5 times 5, add 5 times 5, add 5 times 5. Yeah, I'm loving that. 8 times 8. Oh, that's 64. Oh, 64. There I can see actually a 5 times 5 array and a 3 times 3 array in the red. Oh, I'm loving it. Oh, I'm liking that. Anything else you spotted? I think, Dave, that 3 squared add 4 squared equals 5 squared. Oh, so you're saying that 9 add 16 is 25. Oh, it is actually. So 3 squared 9 add 4 squared 16 makes 25, which is 5 squared. That's clever, isn't it? It is really clever. Anything else you spotted? Odd and even pattern, Dave. Oh, I suppose it is actually, because 1 is odd, 4 is even, 3 is odd. Sorry, it's 9 is odd, 16 is even, 5 squared is odd, 6 squared is even. Oh, it's clever, isn't it? In fact, I reckon there's loads more things hiding in there that we could reason. I wonder about that. Oh, you've changed it, Dave. I've gone to 12 times 12 here because I think this sort of abacus array image is really helpful. 5 times 5 is 25. That's right. So those are square numbers. We've got 4 of those 5 times 5s on there. There's a 5 times 2, lots of 5 times 2 at the bottom, a 2 times 5 on the right, another 2 times 5, and there's 2 times 2 equals 4. A square number. Brilliant. Another square number. And if we add all of those little products up, we get 144. And of course, 12 times 12 is 144. It's a square number, though. It is. It's this array idea of 12 one way and 12 the other way. I'm totally loving it. Well, Dave, well, it's time for this, Alie.
Part 5. What's the challenge?
So we're going to give you guys some challenges, and they're based on this idea that a square number is actually an array image of 5 by 5 if it's 5 squared, or 6 by 6 if it's 6 squared. In fact, here is your first challenge today. How many little lights are there in the football stadium pylons? Use your knowledge of square numbers to solve the problem. There were 4 pylons, and this was all of the little lights that went on the pylons. So how many lights are there? Square numbers, Dave. You're right. I've just arranged it in square numbers. I did it naturally. I can see 2 1 squares. I can see two lots of 2 squared. There's a 3 squared, a 4 squared, a 5 squared, and a 6 squared. There is indeed. So can you guys work out how many lights there are there? Oh, we're back here, Dave. We are. We're back to that thing earlier on. I'm wondering, what does this tell us about the square numbers? What does it tell us about the relationship between 1 squared and 2 squared and 3 squared and 4 squared? I'd like to have a really good reason about that as well. Gosh, there's some great ideas, Dave. It is indeed. So what's going to happen in a moment is I'm going to put up... Oh, hold on. Portal. Oh, the portal. Oh, yes. This is just to remind you, on the Number Fun portal, there's loads and loads of stuff. What I've done here is I've gone to the 9 to 11 age range, squares, cubes, and primes. There's just loads of some of these numbers that we need to work with there, and children need to know and understand prime numbers, square numbers, cube numbers. They're all in there, and in there is also the prime number bashing parent ideas pack, and for children to use at home. Oh, there's the square numbers. Can you see the square numbers in the red? Oh, I can, Dave. And our multiplication grid. Oh, and the square number cards as well to play loads of games with. So please do check those out, because they'll be really helpful in terms of doing your reasoning and your challenges. So in a moment, I'm going to put up the screen with both the pylons on and that array image with the counters on. So you can pause the screen, have a really good think about it. What can you spot? And in a few minutes, we'll be back with Wait Before You Go, won't we? Wait Before You Go. Yeah. Oops, I need to go. No, you don't need the loo now. I've lost my wig. Oh dear, never mind. So there's a parent portal nuggets. That's where the notes are, if you like, that go with this session. So there's a little download you can have of the pictures I'm now sharing with you that might help you. Okay, so we'll be back soon, and we're looking forward to another one. In fact, our next Number Fun nugget is going to be about prime numbers. Oh, I love prime numbers. Yes, so do I. So actually, we'll really try and see if we can master that. So before we do the Wait Before You Go, here's the reasoning screen. They're very nice pictures, Dave. They are. There's just loads of squares on there. Have you noticed? Arranged in squares. They look like circles, though. Well, I see what you mean. They're sort of like, they look circlish, don't they? Yes. But they're arranged in square format. That's what we mean. We better let them get on with it. I think we better had.
Plot 6. Wait before you go.
Don't go anywhere. Don't go anywhere. Because it's time that we're going to have a little look at what we've done. So here, with the pylons, did you work out how many pylon lights there were? 96, Dave. Well, here's our reasoning. We reckoned we'd had, just going from the top right-hand corner, we've got 2 times 2, add 2 times 2, add 1 times 1, add 1 times 1, add 3 times 3, add 4 times 4, add 5 times 5, add 6 times 6, which of course is 96. So underneath we've written that using the indices. So that's 2 squared, add 2 squared, add 1 squared, add 1 squared, add 3 squared, add 4 squared, add 5 squared, add 6 squared. I reckon that's 96. And then at the bottom, we've just written out the products there. So 4, add 1, add 9, add 16, add 25, add 36, 96. Oh, I'm loving it, Dave. I reckon it definitely is that. Okay, that's really good. So, I want to show the board. And I've got a board. I was thinking about this earlier on. If you did have these numbers, I'm thinking, what is there an easy way, a quick way of working out how many there are altogether? And I'm thinking, well, hold on, there's 20. I was thinking, there's 30, and there's another 10 there. So I've got 20, add 30, add 10, 60, add 36, 96. So I just spotted bonds, actually, which is really interesting. I love it, Dave. Right, yeah, love it. Okay, that's that one. Okay, and what else have we got? We've got the reasoning thingy, Dave. Oh, yes, the reasoning thingy with the counters. Now, take a look at this. Oh, it's a picture you took. It is a picture, and that was the counters before I laid them out on the grid. Oh, I can see the numbers going up, Dave. You can indeed. How much are they going up in each colour? 2. They are. So actually, there's a steady increase in the difference between each square number. Gosh, that's a bit clever, Dave. It's a bit stunning, isn't it? So if I go back to one of the reasoning screens we had earlier on. Oh yeah, difference is 3 yellows, then 5 greys, then 7 blue, then 9 greens, and it carries on like that. Yeah, it is, isn't that? That's just a lovely bit of reasoning. I really like it, Dave. So there you are, Alie. The difference between the square numbers is increasing by 2 every time. Does it carry on forever? I think it does carry on forever. It's amazing. It's a pattern. It's a pattern indeed. So it's lovely to see everyone. Thank you for joining us for this Number Fun Nugget. We'll be back very soon with a prime number version. I like prime numbers. I'll have my glasses on. You'll have my glasses on. We'll see you tomorrow if you're able to join us. Bless you. You sneezing, Dave? Why did you say bless you then?